So this is the modern anesthesia workstation, which is very difficult to understand but very easy to operate. This is the monitor of the workstation, which is showing that nitrous oxide and oxygen gases are going on, which are life-sustaining. This is end-tidal carbon dioxide, which is the capnography. This is the minute ventilation of the patient and the tidal volume. This is showing the peak pressures in the airways. The mode pressure control mode is presently going on. This is the place from where air and nitrous oxide and oxygen can be increased. These are actually their flow meters. Now this is the place where we can keep our records as well as our drugs in the workstation. This is the circle system, which consists of the inspiratory limb, which is going to the patient, as well as the expiratory limb, which is coming back from the patient. This is the APL valve. Now this is the emergency cylinders, oxygen and nitrous oxide, which can be used in case of emergency and are attached to the back of the workstation. This whole workstation we'll discuss in detail starting from boils. So here we'll discuss about the soda lime. This soda lime is used for the absorption of carbon dioxide, which is generated in the system. This soda lime is based on the principle that it has some factors which will change the color on acidic as well as on basic medium. It has certain indicators, like if it has blue litmus, its color on acidic medium will be red, while on basic medium it will be blue. Same way, this if it is red litmus, its color on acidic medium will be red, while on basic medium will be blue. If it is methyl orange, it is red, while on basic medium, it is orange. If it has phenolphthalein on acidic medium, it will be colorless. On basic medium, it will change into pink. And if it is China rose, it will be dark pink on acidic medium and it changes to basic medium to green. When this soda lime, it has sodium hydroxide. It absorbs carbon dioxide and becomes soda bicarbonate, and therefore it absorbs carbon dioxide. This needs to be changed once a week. All its properties are dependent upon the mesh size of it which is present, and if once it is exhausted, we need to change it before going on for the next anesthetic session. So now we'll discuss about the cylinders in detail. Each cylinder has a proper color coding as well as it is set at a proper pressure. For example, here we can see the oxygen cylinder. This oxygen cylinder has a black body as well as white shoulders. It has a pressure of 2000 psi. This is nitrous oxide cylinder, which is blue in color and it has a pressure of 760 psi. Similar to the oxygen cylinder, but its color coding is opposite. It has a white shoulders as well as black body and it is of 2000 psig in heliox. Antonox is at a pressure of 2000 psig. There is a blue body and white shoulder. Carbon dioxide is color gray at 750 psig. Cyclopropene is orange at 75 psig. Air has gray black body and white shoulders at 2000 psig. This color coding of the cylinder is a safety feature in anesthesia machine. This is done so that we do not provide wrong gas to the patient. Apart from this, there are other safety features which we'll discuss under safety features. So we'll discuss here the parts in the basic boils apparatus before discussing it into the workstation. As we can see here, the color coding is blue. This is for nitrous oxide. These are the gauges which will tell us the pressure in the nitrous oxide, and these are the gauges which will tell us the pressure in the oxygen. So from here oxygen will enter, and this is the oxygen reducing valve. This is for nitrous oxide and this is the nitrous oxide reducing valve. This is the on and off apparatus for this machine, and this is the oxygen flush valve which will supply the oxygen at 35 to 75 liter per minute. Now this is a nitrolock system. From here, after the nitrous is reduced, this will enter into the nitrolock system. This nitrolock system acts on the master-slave mechanism. This is the oxygen failure device which will sound a whistle once the oxygen falls below the desired level. From here this will enter, and after this there is a Richter whistle also here which sounds once the oxygen falls below the desired level. So this is the oxygen reducing valve. Oxygen will enter from this side and it is the oxygen reducing valve. Oxygen in high pressure system, it is at 2000 psig, but in intermediate pressure system this oxygen reduces to 50 psig. So this work is done by this oxygen reducing valve which is placed over here. So this is a nitrolock system. This nitrolock system has on one side nitrous oxide which is entering from this side, and from this side oxygen is coming. This nitrolock system sustains that nitrous oxide cannot be alone opened. If it opens, some amount of oxygen has to be opened which is up to the desired level for that machine. That desired level has been fixed differently by Datex Omda and other machines, but Nitrous oxide alone cannot be opened. This is known as master-slave mechanism, in which master is oxygen and the slave is nitrous oxide. To make things simpler, this is the gas cylinder which we use at our home. We do not have gases at our home if we do not have a cylinder. Similarly, for oxygen, nitrous oxide, anything, any gas which we are using in our operation theatre, we definitely have a cylinder, and those cylinders are available in various color coding. So this is the pressure reducing valve for the stove which we use at our daily homes. Now, how is this a pressure reducing valve? Every gas has a critical temperature and pressure. For nitrous oxide and cooking gas, critical temperature is above the room temperature. So if we apply critical pressure, it will become liquid from gaseous form. For oxygen, the critical temperature is minus 118.6 degrees Celsius, and for carbon dioxide, it is even lower. So above minus 118, it's in the gaseous form. Liquid oxygen is also available in bigger hospitals in separate oxygen tank. Oxygen and carbon dioxide are in cylinders. At room temperature, they are in gaseous form. So as we had already compared our home cylinder with the cylinder in the operation theatre, and the pressure reducing valve was compared. Now what is this? This is actually the flow meter, by which we can increase the supply of gas as much and when it is required. Similarly, we rotate this in our home for increasing the gas. Similarly, we have flow meters in our operation theatre so that we can increase the flow of oxygen, nitrous oxide and air. Just now we studied the flow meter in our stove. Now this is the flow meter which is used in our operation theatre. See, by rotating this we can increase nitrous oxide, and by rotating this we can increase oxygen. This is also a safety feature of the anesthesia machine again. Why? Because the striations of nitrous oxide and oxygen are different, so that they are touch coded. The color is different. It's blue for nitrous oxide and it is white for oxygen. And they also have a light inside it so that even in darkness we can see it. So this is the flow meters. So this is the pin index safety system. This pin index safety system consists of 7 pins, in which 4 pins are on the left and 3 pins are on the right. This pin index safety system is having a different coding for each of the following gases, so that they do not intermix and we do not put the wrong cylinders in these. This is also a safety feature of the anesthesia machine. For example, if we want to memorize it, it's 152535. It's for air, oxygen and nitrous oxide. 16, 26 and 36. 16 is for oxygen carbon dioxide more than 7.5%. 26 is for oxygen carbon dioxide less than 7.5%. And 36 is for cyclopropene. For nitrogen it is 14, and for nitrous oxide antinox it is 7. So now what is this? This is the back bar. This back bar, what is it used for? It is used for putting the vaporizers in place. It has a selector tech arrangement. What is meant by selector tech arrangement? That at one time you will be able to use only one vaporizer. This is also one of the safety features of the machine, so that no two vaporizers can work together and no two inhalation agents can be given together. This is a part of the low pressure system, the safety bar as well as the vaporizer mounting device. This is the vaporizer. This is Tech 7 vaporizer. We have Tech 1 to Tech 8 vaporizers, which we'll study in another class in detail. So whenever we have to discuss the machine, we always divide the machine system into 3 parts: high pressure system, intermediate pressure system and low pressure system. High pressure system has a PSIG for oxygen equal to 2000 PSIG and nitrous oxide equal to 760 PSIG. In intermediate pressure system, in the pipeline it is 45 to 50 PSIG, and for low pressure system it is 5 to 8 PSIG. Now only there are 3 components in the high pressure. One is hanger yoke, another is the cylinder pressure indicator, and the third is the pressure reducing valve. In the intermediate pressure system we have pipelines, master switch, oxygen flush valve, flow control valves and the oxygen failure alarms as well as the safety device. In the low pressure system, we have the flow indicators, the unidirectional check valve. Here there is also pressure relief device, the vaporizer mounting device, and the common fresh gas outlet. So all of these are the parts of the intermediate, are parts of the low pressure system.